Good morning again, guys. This is the second part of the domain and range lesson. So just picking up where we left off, you have this thing called set builder notation. And there are parts of it that are going to be the same every single time and parts of it that will change. The parts that will change have to do with what values of x and y work for the particular graph you're looking at, as well as what number set it belongs to. Okay, so we did this example. We'll do one more example and then we'll move on. And let's try this one because it looks weird. So we have three different graphs here. They have some similarities. This one is individual plotted points, and there are gaps in between the points. So for this one, it's pretty simple. Your domain and range, you don't use set builder notation if you don't have a continuous string of numbers. So for this one, basically, you simply list all of the x values that apply. So you can see we have a point here that has an x value of 1. We see the next point here has an x value of 4, and the final point has an x value of 5. Okay? With the y values, if you take a look at the y values, they are consecutive. You have one at 2, one at 3, one at 4, one at 5, and one at 6. So for the y values, you can use set builder notation, and remember, it's always starting with y, vertical line, which means such that, and then you say what your lowest value and highest value of y are. Well, your lowest value of y is 2, your highest value for y is 6, and y is in between them. It's greater than or less than 2, greater than or equal to 2, and less than or equal to 6. And then you just go comma, and then you say which number set these belong to. Well, if you think about it, they're all positive numbers. There are no decimals, so this is actually a very small number set. It's the natural numbers. Okay, it doesn't even have 0 in it. So, moving on to this one, which looks very similar, except the plotted points are joined together, you have this nice solid line. Okay? That would have a domain where you have x values such that, now, this is the furthest to the right my x values go, this is the furthest to the left. So that means my x values are in this area here, between positive 1 and positive 5. So that's what I'll put. I have a low value of positive 1, a high value of positive 5, x is between them, it's greater than or equal to 1, and less than or equal to 5. And in this case, because we have a solid line, we say x is an element of the set of real numbers. Okay? I'll just do the domain quickly. Remember, for the domain, we're looking for the highest number, the range, we're looking for the highest number and the lowest number. For our range, it's the set of all y values such that y goes from 2 at the lowest to 6 at the highest. So 2 to 6, y is in between those two values, greater than or equal to 2, less than or equal to 6. And again, just as with the domain, y is an element of the reals. Okay? This one is only different in that you'll notice this line goes right to the edge of the graph. And what that means is it goes all the way to infinity, both to the left, and as you can see, it's sloping down, so it's going to go all the way to infinity down, all the way to infinity up. Okay? Let's do the domain first. So again, x such that, now in this case, the extreme left is actually negative infinity. So that's our extreme at the bottom. Our extreme to the right is at 5, and x is in between them. It has to be greater than negative infinity. It can't equal negative infinity, and less than or equal to 5. And again, since we have a solid line, we say x is an element of the set of real numbers. Okay? Now for the y's, it goes down to negative infinity eventually. You can see it sloping down. And it goes up to positive infinity eventually. So we can say our y values such that we go from negative infinity to positive infinity. Y is in the middle, has to be greater than negative infinity and less than positive infinity. And y is an element of the set of real numbers. Okay? Another way to write this, because you can say y could be any possible number, right? All the way from negative to positive infinity. A shorter way of writing this would be to say y such that y is an element of the set of real numbers. Okay? In other words, we just get rid of this middle part because y can be any possible number. So you don't have to specify. It can be anything. And that's why we just say y can be any real number. Okay? So that's a shorthand. Most of your grade 11 math teachers are probably going to ask you to write it that way. Okay? So we'll move on. I'm not going to do any more of these. Remember, most of your learning should be done using the module booklet that I sent you, as well as your textbook. Okay, so these are just some examples to try and clear things up that might be giving you grief. Just a real quick look at number lines. And I'm only going to do a couple of these. So it asks to draw number lines to represent each of the following. We'll do this for domain, but it's exactly the same process for range. Okay? So if we have a number line, and this is what we're given. X has to be greater than or equal to 4, and x has to be an integer. Now our number line just has to include what we've been told to include. So what I'm going to do is I'm going to start it at 3, and then 4, 5, 6. Okay, that's good enough. Now x has to be greater than or equal to 4, so the first number that would apply would be 4. Since it's greater, we go in this direction. We're going to put a nice black dot on each of the numbers, and we're going to make this arrow a little bit thicker, just to show that it goes on forever to the right. Okay? Why have I put dots here? Because only the set of integers is included, so we don't have any in-between values, right? Remember, integers do not include any decimal numbers. So for our set notation, again, we're going to say values for x such that we have a low of 4 and a high of infinity. So 4 is the smallest number, infinity is the largest, and x is between them. It has to be less than infinity, greater than or equal to 4, and x is an element of the set, this time, they told us this, the set of integers. Okay? For our interval notation, the low is 4, and since it's included, we use a square bracket. Remember, this goes back to the last lesson. And we have a high value of infinity, and infinity always uses a curved bracket. I know that looks a little bit weird when you have one of each, but that's the way to do it. Okay? We'll do this one actually we'll do number 3 because it's a little bit different. Okay, so for number 3, actually no, we'll do number 2. x less than or equal to -2, and this time we're looking at the set of real numbers. Okay, so we're going to start with -1, -2, -3, -4. Okay, so we know that the first number that works is -2. And then x has to be less than that. So this time we're going to the left. And since we're dealing with real numbers, we have to make a solid line going all the way down, and we also make the arrowhead solid. What this says is all those in-between numbers are also included. So for set notation, we say x such that, well, my lowest number would be -infinity, my highest number, -2, and x is in between. Okay, it has to be greater than infinity, not greater than or equal to, and it has to be less than or equal to -2, and we've been told we're dealing with the set of real numbers, so x is an element of the set of reals. Okay, for our interval notation, our smallest value is -infinity, our biggest value is -2. Since the -2 is included, we use square brackets at that end. Since infinity is never included, we use round brackets at that end. Okay? Okay. I guess we may as well get rid of that, hey? There we go. Okay, let's continue on. Now, there are a zillion examples I could do of this with you. We're only going to do a couple more, okay? You've got lots of examples in your module booklet, lots of examples in your textbook. Please make sure you refer to those if you're having any troubles, okay? So what we've been asked to do in this question is simply state the domain and range using both set notation and interval notation, and it says where possible. So sometimes it's not possible to use something like interval notation. For instance, in this one, you can see that for my x values, I have 1 at -2, but I have nothing at -1. So I can't use interval notation or set notation. I'll be right back because my phone is ringing. Okay, sorry about that. So, as I was saying, you can't use interval or set notation for the domain. So we say can't. Anytime there are values that aren't covered, so in other words, if you don't have consecutive values, you can't use set notation or interval notation. Now, if you look at the range is okay, because you have a low at 1, you have something at 2, you have something at 3. So you have consecutive values. So for the range, you're good. You have a low at 1, a high at 3, and so your range simply becomes a low of 1, a high of 3. We use square brackets because 1 and 3 are both included. If we want to use set builder notation, we say y such that we have a low of 1, we have a high of 3, y is in between, greater than or equal to 1, less than or equal to 3, and in this case, the smallest number set would be the whole numbers. Okay? Because you can see that there is a number that involves 0. So safest to just say whole numbers. Why don't we try F? Because it's a little weird. It's a circle, and that sometimes can throw people off. But remember, for our domain, we're simply looking for what are our extremes to the left and to the right? So what's the furthest x value to the left and the furthest x value to the right? And those parameters are at 0 and 4. So for interval notation, we put the smallest number, the largest number. That was easy, we're done. For the set builder, again, squiggly brackets, we use an x because we're referring to the domain, such that x has to fall between 0 and 4. So 0 is the smallest, 4 is the largest, x has to be in between those, greater than or equal to 0 and less than or equal to 4. Since we have a solid line, we say that x is an element of the set of real numbers. Okay? For the range, again, you're looking for the extremes. The lowest value is at -1, and the highest value is at 3. So very quickly, again, we have square brackets with the lowest value at -1 and our highest value at 3. For our range, we say values of y such that a low of -1, a high of +3, y is in between, greater than or equal to -1 and less than or equal to 3. And also, solid line indicates that y is an element of the set of real numbers. Okay? We're going to do, let's see what we have here. Yeah, we're going to do one more, maybe two more. And then we'll be done with this. So, this one looks weird, right? It's a zigzaggy line, and that might cause you some grief. But remember, all you're trying to do is, for domain, you want to find the point that's furthest to the left, and that's right here. And you want to find the point that's furthest to the right. That's that one right there. So your domain has to cover from a minimum of -4, that's your lowest x value, to a maximum of +2, your greatest x value. Putting that into set builder notation, again, squiggly line, x, such that we have a minimum of -4, a maximum of +2, x is in between those values, greater than or equal to -4, less than or equal to 2, and because we have a solid line, it has to belong to the set of reals. Okay? For our range, same deal. It's just that now we're looking for the extreme, the highest and the lowest, instead of left and right. So our lowest y value is right here at -3. Our highest y value is right here at +2. Since they're both included on the line, we can use square brackets. Y such that low of -3, high of +2, y is in between, greater than or equal to -3, and less than or equal to 2. And again, it's a solid line, so we say y is an element of the set of reals. Okay? Any questions? I guess that was a stupid thing to say, because this is a video. We'll do one more. One more, and that's going to be one. Now, if you take a look here, you see something that we haven't seen before. You see open circles. Okay? So why don't we do number 4? Now, all an open circle indicates is that that particular value is not included. And you'll see that that just changes things slightly. So let's take a look at the domain. And we have at the extreme left, -4. But remember, this open circle tells you -4 isn't included. It goes all the way up to -3.9999. but not to negative 4. Similarly over here, we have an extreme at the right side of 2. So when we use interval notation, we're not using square brackets, right? We're using the round guys because they say that this number, negative 4, isn't included. Everything up to it is, but not quite negative 4. Similarly, positive 2, round brackets. Now, we show this in set builder notation slightly differently. So again, squiggly bracket, x, such that we have a minimum value of negative 4, a maximum value of 2. So far it's exactly the same. X goes in between. This is where it changes. Instead of greater than or equal to, we're just going to say x is greater than negative 4. Okay? It can't be exactly equal, but it can be just a little bit bigger. And similarly, it has to be less than 2, not quite there, but almost. And finally, x is an element, because we have a solid line, of the set of reals. Okay? For our range, it's a little bit different because our highest value for the range is at negative 1, and since again we have an open circle, it's not included. But our lowest value at negative 3 is included. So this is where we're going to have that weird thing where one of our brackets is square and the other one is round, because negative 1 isn't included, but negative 3 would be. And for our, I hope you can see that. I'll tell you what, why don't we just write the range beside it, and that way you'll be able to see it. Okay? So the range is y values such that you have a low of negative 3, a high of negative 1, y is in between them. Y can be greater than or equal to negative 3, but it has to be less than negative 1. And y is an element of the set of reals. Sorry, you can see that. I almost asked if there were any questions again. It's hard to break our habits. Okay, I think the rest of this you can get from your textbook. Maybe we'll do, did this ask for? Yeah, this asked for set notation. We're running a little long on time, so I'm going to do this one, and then we'll be done. We can also use set notation. If we have consecutive numbers, we can use set notation even if we're given the domain, all x values, and the range, all y values, even if we're given them in a table of values. So, for your domain, you can see that we do have consecutive values, right? There's nothing missing here. So we can say that our domain is all values of x between a low of negative 8 and a high of positive 2. X is in between, has to be less than or equal to 2 and greater than or equal to negative 8. Now, because there's no indication that decimals are included, we always go for the smallest set, and in that case, it's the set of integers. Okay? Taking a look at y, they've been kind of nasty, they've mixed things up on us. We can figure that out. Do we have consecutives? Well, we've got an 8, a 7, a 6, a 5, 4, 3, 2, 1, 0, negative 1, negative 2. So even though they're mixed up, there's nothing missing. They are consecutive. And they go from a low of negative 2 to a high of 8, just like the domain. So our range becomes y values such that we have a low value of negative 8, a high value of positive 2, y is in between, has to be greater than or equal to negative 8, less than or equal to positive 2. And just like with my x's, my y's belong to the set of integers. I hope that helps. Again, remember, check your module booklet, check your textbook. Hopefully you'll get through this. Good luck, guys, and see you next time.